Hey physicists, what's the crack? So today we're going to see how do we use SUVATs to solve the speed of the ball just before it hits the ground. Okay, so what I would do first is pictures always help me. So I would draw a diagram. So it says I've got a cliff and the cliff is 50 meters in height. So I'd write the 50 meters in height on my picture. Then it says a person drops a ball. So I've got a person standing here and they're going to drop a ball. Okay. So the first thing I know, if I have a ball in my hand and I was to drop it, the starting speed or the initial speed is going to be 0. Okay. Then as I drop the ball, the only force acting on it is the downward force due to gravity. So I know the ball is going to accelerate downwards at negative 9.81 meters per second squared. Okay. So what I do then to find the speed just before it hits the ground, I'm going to use my SUVATs. So to set up my SUVATs, I'm going to write U, V, S, A, T. Okay, so I know the initial speed is 0. The final speed is what I'm trying to calculate out. It is falling downwards, so that's why it's going to be a negative 50 meters, right? Because in my diagrams, downwards is always going to be negative, and then upwards is always going to be positive. Okay. So it's falling downwards 50 meters. I know the acceleration is always downwards due to gravity. Things always accelerate towards the center of the earth. So I pop that number in, and I don't know time. Okay. So I think for my SUVATs to see what SUVAT I have on my data sheet that has U, V, S, and A in it. And then when I look through them, the one that makes sense is V squared equals U squared plus 2AS. So I just fill it in my data. So I have V squared equals 0 squared plus 2 times negative 9.81 times negative 50. Okay, so then 0 is just 0. So V squared equals 2 times negative 50 is negative 100 times negative 9.81. I get 490.5. But again, I remember that's V squared. So in order to find just what V is, the final speed, and you take the square root of this answer, and when I take the square root of this answer in my calculator, I get 22.15 meters per second. Okay, and that's then the final speed of the ball just before it hits the ground.